Hello everyone, this is Mr. John from Areteem Institute with this week's Thursday Tidbit, where we're continuing from the video last time. So if you haven't watched that, check it out in the link below. And we're going to be continuing to talk about correlation, causation, prediction, data, things like that a little bit today. So let's do a quick review of what we did last time. Alright, so given some sets of data, we might want to determine whether there is a relationship between them. And we posed two specific questions that we wanted to study a little bit or examine a little bit from last time. So first of all, this was, is there a relationship between age and height? So this was actually more specifically looking at the height of boys, and we wanted to say, is there a relationship there? And the other one is there a relationship between winning the coin toss and losing the game at the Super Bowl? So we'll review that data a little bit and then talk about some specifics from there as well in the coming slides. Now, right, let's do a quick review of causation and correlation. Correlation is the mathematical determination that, right, there's some nice relationship. When one goes up, the other goes up. When one goes down, the other goes down. That's a mathematical thing. That does not mean that one thing is caused by the other. Now, one of the questions we want to think about today and look at today is we also want to begin thinking about and asking this question of what data are we examining? Now, we haven't talked too much, and we're not going to get into too much specifics here, but there's a lot of good questions you could ask. One of them is, do you have a large enough sample size, right? So are you looking at enough data so that you can actually draw some conclusions from it, right? Is your data set complete? Now, notice that we have complete in quotes. We have large enough sample size. These are questions that do not have easy answers. There's not easy ways to think about these things and answer these things. So you do have to be careful with these questions, and you want to be asking these questions, but it really depends on the circumstances you're dealing with, and different examples might have different ways of approaching these ideas. We'll talk about them a little bit with what we have today for our data sets here. Quick review of the questions we did and posed last time. So for next year's Super Bowl, the coin toss question, do we think the winner of the coin toss is less likely to win the game? Why or why not? And then based on our age versus height data, can we predict the height there? So let's tackle the more natural one of the age and the height here first, right? So we have our age versus height data. We have it in chart form here. So we have the age in years of the boys, their height in inches as they are growing that way. And we want to predict future heights from there. So with some data analysis, right, there's lots of different ways you can do this, but a natural way to do it here is trend lines. So here we have a linear trend line. So when we say a trend line, you're kind of doing a line of best fit or something like that. And we have a couple of predictions that could be made. So here we have our trend line. So they're saying it's roughly a linear equation with a slope of around 3 and a y-intercept about 23. Notice that these trend lines themselves can give you some information. This is roughly saying that the boys are growing 3 inches per year. They start out roughly 23 inches tall and things like that there. So we now have two predictions that we were asking about, and our trend line could be used to make those predictions. So first one here is a height of 59.5 inches at age 12, right? So here we have that this is, okay, well, if we're more used to looking at feet or something, right, 59 inches, this is a little less than 6 feet, so this is approximately 6 feet, we could say there, right? And, sorry, not 6 feet, 5 feet there. So we have 60 inches is 5 feet in that case. And this one is probably a pretty decent prediction, right? We could look back at the data. Let's not worry about that right now. But we could also look here at our second one. So we have a height of roughly 113.9 inches, right? And this is almost 10 feet tall, right? So this is a little less than, right, 10 feet tall, or kind of 9.5 feet tall, if we like there. And this one, right, probably is not a good prediction. So we have a bad prediction in this case. Now, what is the point I want to bring up here, right? So we said there might be two questions to examine. Do you have a large enough sample size, right? So we're taking this data from online. We can trust, or we are, let's say for the sake of argument, trusting that this is a large enough sample size of boys in the US. Like I said, that's a difficult question to examine and ask, generally speaking, but let's just take that for granted here. Now, what's the issue with age 30? Well, we have ages between 0 and 10, so going to age 12 is a little bit farther. Mathematically, the trend line is, right, a line of growth, and we have that data there. So mathematically, there's nothing wrong with our prediction. Practically speaking, however, we're missing a very important thing. The fact that people typically stop growing at some point, right? So this is assuming that growth happens and is happening at the same rate the entire time, which we know from the background is false. But this, right, is a good question of, okay, how far out can you predict the data? Do you expect things to change in the future? Right, so these same type of things could be talking about growth of a company, right? Maybe they grow in the beginning, but then it tapers off. And so if you're making these linear predictions, maybe that's not the best way to go. Maybe you shouldn't try to predict that far in the future. So there we're kind of missing data that definitely affects things, because we know, right, from other pieces of information, if you would look at the full heights for their entire lives, you would see that they stop growing at some point. Now, let's examine our Super Bowl coin toss as well. Right, so we know that over the last 8 Super Bowls, the winner of the coin toss has lost the game. Now, this brings up a very important question, which is a pretty obvious question, but these types of things crop up in everyday life all the time. The question here is, why last 8 Super Bowls? And that is a very good question. Well, practically speaking, why the last 8 Super Bowls? You can probably guess that the 9th Super Bowl in the past, the winner of the coin toss won the game. So that ruins our little story we're telling with this, oh, the last 8 times this thing has happened. And again, right, we might ask, right, is there something special about the last 8 Super Bowls? Probably not, right? You might want to look at that. This could prompt you to examine, did they change the rules in some way? Has something major changed over the last 8 years? But if not, you might want to look at, well, how about all of the Super Bowls? So, right, during the last week, I collected the data from the 56 Super Bowls that we had in total. So there were 56 in total. 24 times the winner of the coin toss won the game. and 32 times the winner of the coin toss lost the game. So 8 of those times, right, where this winner of the coin toss lost the game. The last 8 fall in this second category, but in total there were 24 and 32 of each. So we still have a slightly interesting result here, right? Actually, 57% of the time, the winner of the coin toss actually lost the game. So that still might be a surprising result. Now, we could still ask the same questions there as well, right? So what would be a natural question you might ask here, right? And this depends on knowing a little bit about football, right? But you might ask, why the Super Bowl? So there could be something special happening in the Super Bowl again, right? It's the final game. Maybe you want to say teams are preparing more or extra nervous or things like that. So maybe the Super Bowl does actually affect things. But you might want to compare this to all the games, right? Or all the games in the past 8 years if you want to look at recent data and things like that there. But basically, right, what I want to stress here is that it's very important to look at the data sets. It's very important to look at what you're examining, right? There's a pretty famous saying here, right, that stats don't lie, right? If you look at the numbers, right, the numbers aren't lying to you. So sometimes this would be numbers don't lie, stats don't lie. But we want to make sure that it's clear that they can be misleading or misused, right? I'm not lying to you when I say the last 8 years, the winner of the coin toss lost the game. But, right, that's ignoring the other 48 games that came before it, or ignoring all the other regular season and playoff games there. I'm not lying to you about the age of the boys and the trend line that we have. But right, we're missing what happens when they stop growing. So you want to always examine and be conscious if you're producing results, what data sets you're looking at, and making sure that you're not missing things that might be important. And a good rule of thumb is that the mathematical results should prompt questions about, why is this true? Does this make sense? Can we explain that using other rationale as well? Real quick, I want to put the heights source I had from before. I also have a Google Doc share of the spreadsheet for the Super Bowl coin toss winners. I will link that below as well if you want to take a look. But other than that, thank you all for watching. If you like this video, please give us a like, subscribe, share any ideas you have for future videos, right? Remember, it doesn't need to be a full topic. It could be a video game, movie you're excited about, and you can challenge me to find the math in there, and I'll do my best if I have a chance. Otherwise, hope to see everybody next time. Goodbye.